Hello, so in last class we have seen what is an orthonormal system, and in today's class we will look at what is called an expansion problem. Okay, so suppose you are given a set of functions are an orthonormal system. So so you are given a set phi n, so be an orthonormal system with respect to the weight function or on an interval a less than or equal to x less than or equal to b. So you are given an orthonormal system with respect to the weight function r on the interval a less than or equal to x less than or equal to b, and let f be an arbitrary function. By expansion problem we mean so our aim is to write f as an infinite series which is involving the functions phi 1, phi 2, etc. phi n. So the problem is to give an expansion of the form summation n equal to 1 to infinity cn phi n of x. So we need to find out if such an expansion exists, what can be the possible value of cn. So this problem is called the expansion problem. So here given a function, given an arbitrary function f of x, so we are expanding that arbitrary function in terms of the functions in an orthonormal system. And this such technique has many application in solving many differential equations, ordinary differential equation, partial differential equations are solved here. So we use this series expansion of functions. Okay, so the basic problem under consideration is to expand the function f in an infinite series of orthonormal functions phi 1, phi 2, phi 3, etc. Or that is f of x is equal to summation n equal to 1 to infinity cn phi n of x for each x in the interval a less than or equal to x less than or equal to b. And now assuming that the expansion does exist, we need to determine the value of cn. So assuming that the expansion does exist, we need to find cn's. Okay. Now we are assuming that such an expansion exists. അപ്പോൾ നമ്മള് അതിന്റെ കൺവേർജൻസിനെ പറ്റി ഇപ്പം ബോദർ ചെയ്യുന്നില്ല. So this is a function, this is a series of functions. So you have the point-wise convergence and uniform convergence. Okay. we are not bothered about whether actually f of x converges to cn phi. അപ്പോൾ നമ്മളൊരു assumptionലാണ് cn കണ്ടുപിടിക്കാൻ പോകുന്നത്. That means we are assuming that f of x is equal to summation n equal to 1 to infinity cn phi of n. And now if the condition is so, then we are going to look at what is the value of cn. Okay, so convergence in the condition ഒന്നും നമ്മളിവിടെ നോക്കുന്നില്ല. That is out of the scope of your syllabus. So we are not looking into the convergence. So we are assuming that f of x is equal to summation n equal to 1 to infinity cn phi n, and provided this assumption, we will find out what is the value of cn. Okay. So assume that the orthonormal expansion exists. Then we have f of x is equal to summation n equal to 1 to infinity cn phi n of x. I mean, now you multiply f of x with the function phi k of x. അപ്പോൾ ഇക്വേഷന്റെ രണ്ട് സൈഡിലും phi k of x ഉം r of x ഉം വെച്ച് multiply ചെയ്യും. So that will give summation n equal to 1 to infinity cn phi n of x phi k of x r of x. And now integrate on both sides with respect to x from a to b. So that will give integral a to b f of x phi k of x r of x dx. So that will be equal to summation n equal to 1 to infinity. Cn is constant. So integral a to b phi n of x phi k of x r of x dx. Okay. And now when n is equal to k, അപ്പോൾ നമ്മുടെ phi n's എന്ന് പറയുന്നത് ഓർത്തോനോമൽ ഫംഗ്ഷൻ ആണ്. അപ്പോൾ n equal to k ആകുമ്പോൾ ഇന്റഗ്രലിന്റെ വാല്യൂ 1 ആവും. And when n is not equal to k, the integral will be equal to 0. So this integral a to b phi n phi k r dx, so that will be equal to 1 when n is equal to k, and is 0 when n is not equal to k. So therefore integral a to b f of x phi k of x r of x dx will be equal to, അപ്പോൾ n equal to k വരുന്ന കേസ് മാത്രമേ വരുള്ളൂ, ബാക്കിയെല്ലാം 0 ആണ്. So therefore you will get ck ni ck n equal to k വരുമ്പോൾ ഇത് ck ആവും, ഇന്റഗ്രലിന്റെ വാല്യൂ 1 ആവും. So therefore ck is given by integral a to b f of x phi n of phi k of x r of x dx. So therefore cn is obtained as integral a to b f of x, so phi n of x r of x dx. So therefore this is how we obtain the coefficients cn in the expansion. ഇനി നമ്മൾ അതിന്റെ കൺവേർജൻസ് കണ്ടീഷൻ ഒന്നും സ്പെസിഫൈ ചെയ്യുന്നില്ല. So if it converges, so this is going to be the value of cn. So thus under suitable convergence conditions, the coefficient cn in the expansion f of x equal to summation n equal to 1 to infinity Cn phi n of x are given by the formula. So Cn will be equal to integral a to b f of x phi n of x r of x dx. So here n is equal to 1, 2, 3, etc. So this is how we obtain the orthonormal expansion of a given function. And now we will state the basic convergence theorem in which the system phi n is an orthonormal system and it is the characteristic functions of Sturm-Liouville problem. നമ്മൾ Sturm-Liouville function orthonormal system. So for Sturm-Liouville problem, you will get orthonormal characteristic function. We'll see how to expand a given function as the characteristic functions of the Sturm-Liouville problem. So we will look at the basic convergence theorem. So we are not going to see any proof. So we will just see the theorem. So we are concerned with the case in which the system phi n is a system of orthonormal characteristic functions of the Sturm-Liouville problem. So let us look at the theorem. So the theorem is consider the Sturm-Liouville problem d by dx of p of x into dy by dx plus q of x plus lambda r of x y equal to 0. And you have the boundary conditions a1 y of a plus a2 y dash of a equal to 0 and b1 y of b plus b2 y dash of b equal to 0, where p, q, r are real functions and p of x is a continuous derivative and q and r both are greater than 0, are continuous, and p and r are greater than 0 for all x on the interval a less than or equal to x less than or equal to b. So this is the Sturm-Liouville problem. Sturm-Liouville problemത്തിന്റെ ആണ് സ്റ്റേറ്റ് ചെയ്തിരിക്കുന്നത്. And let lambda n be the characteristic values which are in the monotonic increasing form. So you will have lambda 1 less than lambda 2 less than lambda 3, etc. And phi n be the corresponding characteristic functions. So this is the set of orthonormal characteristic functions of the given problem. Now let us move on to the theorem. So this part of the theorem says what must be the condition on f. So നമ്മൾ f എങ്ങനെ function ആയിരിക്കണം. So let f be a function which is continuous on the interval a less than or equal to x less than or equal to b as a piecewise continuous derivative f dash on a less than or equal to x less than or equal to b and is such that f of a equal to 0 if phi 1 of a equal to 0 and f of b is equal to 0 if phi 1 of b is equal to 0. Then the series summation n equal to 1 to infinity Cn phi n, where Cn is given by integral a to b f of x phi n of x r of x dx, where n is equal to 1 to 3, converges uniformly and absolutely to f on the interval a less than or equal to x less than or equal to b. So this part of the theorem says what must be the peculiarity of f. F angana choose cheyanam, and if f is so, then you can find a series of the form summation n equal to 1 to infinity